Hello friends, welcome to YourPedia. And as you know, we have started the concept through question series for the HPCL and the other related exams, right? And today I'm going to start this concept through question series for the subject machine design. And we will be picking up some topics one by one, and therefore over a period of time we will be discussing a lot of questions over there, which may be on the similar lines as you can expect in your exam. And okay, your preparation is going to be quite good that way. So today I have taken those the questions basically from the two topics. The one is from bolted joints and the riveted joints. So that I will be discussing with you, and you will be able to revise your concepts as well. Okay. So just let us go ahead, and this is a question for you. So just see this, and it says a single strap butt joint is always in what kind of shear, right? You already know you are having three main configurations, and out of those three main configurations, like you're having, one is a lap joint, other one is a butt joint. But in butt joint you could have two configurations where you are joining the two members. Let us say these are the two members with the help of what? With the help of the strap, single strap. So these are the two plates that say you have joined, and what I'm doing is with the help of a strap I'm joining these two plates. So obviously, as you can just see over here, so you are having a one rivet over here, or maybe one row of rivet or two rows of rivets and all that. So these are joined. Let us say I'm taking only one row of rivet in each plate. Let us say so they will be uniform. So this way. Now since you're applying the load over here, now tell me what this is going to do. So this force is going to basically pull this plate in this direction. So, and obviously you're going to have the same reaction on the other end, and therefore this portion, that means this section over here, you're having a strap, and strap will be resisting, and therefore this force will try to take this plate in the forward direction, and therefore this will try to shear this rivet over here. That means the bottom portion of the rivet will try to go along this way. Same situation is going to be on the other side also, as the plate is trying to move in this direction. Then over here you're going to have the shear, which is getting, because it is an interface and this is going to be sheared this way. Over here it was getting sheared that way. So this portion of the rivet is going to come along this, and therefore it is going to shear this portion of the rivet. Now in each rivet, how many cross-sectional areas are getting subjected to shear? You will say there is only one cross-sectional area which is getting subjected to shear. So this becomes the case of single shear. Only one cross-sectional area is getting subjected to shear. You can recall one more kind of joint where you are going to have a similar situation. That is a lap joint. So in lap joint you are simply joining the two plates together. So, and over here let us say I'm joining these two plates. So over here you are having this. So see, one plate is this way, the other plate is moving this way. So when this happens, then this cross-sectional area is getting subjected to shear. The lower plate will try to take this portion along with it in this direction, whereas the upper plate will try to take this portion along with it in this direction. So that means it is getting subjected to shear along this. So only one cross-sectional area of this rivet, that is this, is getting subjected to shear, and therefore it is always, this is also always in single shear, and this is also always in single shear. The correct answer is going to be the answer A. So let us move on to the this next one question on the similar lines, right? That is a double strap butt joint. I hope what is the meaning of double strap, right? That means you are using the two cover plates to join the components with equal straps, is always in single shear. While designing it, you already know, right? When you write the stress equation, you already know what kind of what kind of stresses these joints are subjected to. Recall this as simple as that. So for example, if you say the double strap butt joint, so I am having these two plates, so it means I need to join, let us say this is a joint over here, right? So these two plates will be joined with the help of the strap. So let us say you are having this one strap over here, and the other strap, or you can take cover plate, you also call it as a cover plate. So when you apply a load over here and you are having the rivets, it could be one row or it could be two rows depending upon the configuration. Let us say I'm taking two rows, so you are having this way over here. Same is the situation you're going to have over here also. Let us say these are the two rows of rivets in each plate which are getting subjected to this particular kind of loading. Now tell me, when you will pull this plate, in this direction, this portion of the rivet, this portion of the rivet, they will be pulled in that direction. On the similar lines, this portion of the rivet and these rivets over here, they will be pulled in this direction. When this portion is pulled, think of the situation over here. Think of the situation over here. Think of the situation over here. In all the rivets in this plate, as well as in all the rivets in this plate, you are having two cross-sectional area. एक ही rivet है, उसके ऊपर एक cross-sectional area ये है, second cross-sectional area ये है, which is getting subjected to. This is getting sliding this way, or over here, this is getting slided this way. So two cross-sectional area are resisting this force particular. Each rivet is resisting in shear, right? That means two areas are getting shear. Two cross-sectional area of each rivet are subjected to shear. That is why, since two cross-sectional areas are getting of each rivet is subjected to shear, that is why we say they are in double shear. That means each rivet is in double shear. Same is the situation on this side also. So that means they are always in double shear. So a double strap butt joint with equal strap is always in single shear. No. When we talk about the double strap butt joint, it is only the rivet which is getting subjected to shear. So even if he is not mentioning, it is understood that he is talking about the rivet. So is always in single shear? No, it is always in double shear. In a single, this is no, either in single shear or double shear, any one of these. No, it could not be that way. If you are pretty clear about the configuration, then I don't think that you are going to commit the mistake. So correct answer is B. Next question. So here we have the next question where you are supposed to find out the crushing resistance required to crush the rivet per pitch length, right? So you already know, let us say if I am having a joint, let us say if I am taking the lap joint, okay, for the okay, let's say this is the situation, and applying the force P on both the sides, and let us say for example I am having this and this, right? So in this lap joint, if I ask you, let us say if your configuration is given and this is the width, okay, width is known to you, and if I ask you, these are the four rivets which are over there, and if I ask you to find out the what is the crushing stress induced in the rivets, so then you will say crushing stress is equal to simply the force divided the area which is getting crushed. So since all the rivets will subject the will be subjected to crushing because you are pulling it from this side. So see all these four rivets, let's think of the bottom plate. So over here it is getting subjected to crushing because your whole portion is getting of that particular plate is offering applying the load this way, crushing load. So same way on the plate also the same amount of crushing load will be acting. So this portion, half portion of that particular plate whole will be exerting the force over here as well as over here. So if I talk about the bottom plate only, let us say, so T is, if T is a thing, that means this portion of this rivet, this portion of this rivet, and this portion of this rivet, and this portion of this rivet is resisting this particular. So this is the, this portion is getting crushed. That means all the rivets which are over there, they are getting subjected to crushing. So what is the crushing area? So what we do is we take the projected area of the rivet, right? So I hope you have seen the stress formula. So in this case, we take the projected area of the rivet. So projected area of one rivet is how much? You say this is the thickness. When you will project this diameter from here, that diameter will look like a width. Just see from the front. If you apply, project it, so this diameter will be a linear line, that is a diameter, width will be equal to the diameter. So if I project it, I will have this way. So thickness of the plate, and you are having the, let us say this is the thickness of the plate, and this will be the diameter of that particular this, or if you project it, this becomes this diameter. So this becomes the width, right? That way you can say. So how much is that? This is the, if you project the rivet, so it is equal to the diameter. So this is the diameter, right? So that means the area which is getting subjected to the crushing, we say this is the projected area of each rivet. So how many rivets are over there? You will say there are four. So what is the projected area of one rivet? You will say this is the projected area, dr into t, rivet ka diameter, and this. And how many rivets are over there? You will say projected area of this plus projected area of this plus this plus this, and all the rivets which are over there, they are getting subjected to crushing. So load acting over here, or either you calculate for this plate or this plate, the load divided by the crushing area. That is how. So same way we can write the, but sometimes you are not given the width of that particular plate, and you don't know how many number of rivets are over there. So sometimes the situation may arise this way also. That is I'm having a rivet over here, another rivet over here, this way, but you don't know number of rivets. So in that case, you carry out the calculation on per pitch length basis. Per pitch length basis mean what? This is what? Okay. So this is the pitch. That is a linear pitch. Linear pitch means the center to center distance between the two rivets in the same row. या तो यहाँ पर या यहाँ पर बात एक ही है. Now I want to find out the in this pitch length, and I will assume that is the width is equal to the pitch length. So, or simply as simple as that, I had to calculate based upon this, at this particular pitch length, how many rivets are getting subjected to crushing. So earlier you were saying the rivet portion. Now in this length, which portion of the rivet is coming into? So this portion of upper plate, one rivet and another rivet, same situation exists for the next all those. So now tell me which portion is getting subjected to crushing. You will say this portion and this portion. So half or half, again it becomes one. So it means earlier this was the portion which was getting crushed. Now of this particular rivet, now this portion is getting crushed, this one, and of this portion is getting crushed. So this portion is getting crushed. Okay, which one? This and this. So if I project it now, earlier I was projecting the diameter, total diameter, so it was coming out D, but now I am projecting only D by 2 and D by 2. Again it is going to become D. So in per pitch length, how much is the diameter that is coming, which is projected diameter? You will say D by 2, and same here D by 2. So this will become what? D. Or you can say one rivet is coming into play. So if I write the formula, in terms of formula, if I want to write, right? So I will say, let's say you are having only one rivet. As of now, not one rivet. As of now, you are having only one row, let us say. Forget about this row. So I'm talking about this one row, and let us say this is the per pitch length. So how I'm going to modify this formula? You will say that what is the force acting? You will say again the force acting is same. What is the projected area within this particular pitch length? You will say dr into T. As simple as that. This is how you're going to have. So you are writing as dr into T. Why? Because D by 2 and D by 2. Thickness is same. So it is going to be this. So that means over here in the same formula, if you see it, n comes out to be 1 only. But let us say, since you also know that there is not only one row of rivet, there is another row of rivet also. So all the rivets in all the rows are getting subjected to crushing. So यही नहीं crush हो रही है, but ये वाला portion भी तो crush हो रहा है. So when we see in the same pitch length, you are having another rivet. So that means which portion of this rivet is also in this pitch length is getting crushed? You will say this one, this one. So is this formula is going to be valid? So you need to modify what? That if as the number of rows are increasing, then how many rivets are getting subjected to crushing? So it was d by r by 2 plus एक और हो जाएगी आपको, because this portion, half portion will be subjected to crushing. So you can say this portion, this and this. Again, same way like you were saying, if you project it, it will come out to be what? dr into T. Projected area of this plus projected area of this. So it turns out to be total projected area becomes dr into T, right? So it means as the number of rows will increase, this you need to add up. That means, so in general, how I can write it? I can write it this way: force divided by dr into T into number of what? Number of rivets which are getting subjected to what? Crushing. So number of rivets, जब एक रो थी, number of rivets कितनी हो जाएंगे? अब देखो, it becomes pretty simple. When you are having only one row of rivet, forget about it. अब इसको भूल जाते हैं. When you are having only one row of rivet, how many rivets were getting subjected to crushing? You said this portion plus this portion. That means n become 1, because earlier it was n will become equal to 1. So it will become a P divided by dr by t. That is how I had written earlier. Now, as one row of rivet, one more row of rivet is added, then how many rows of how many rivets are getting subjected to crushing? You will say it will be 2, because half of 1. So 2 rivets are getting subjected to crushing. So that means projected area of 2 rivets are getting subjected to crushing in the per pitch length. So that means n will become 2. So it is same thing, isn't it? So you will add one row of rivet. If let us say you add one more row of rivet, then obviously what is going to happen? This half of this portion again is going to be added, because that will also be subjected to, this portion will also be subjected to, projected area is going to be this one. Sorry, I took it this one. So that means this is going to be this. So this projected area is going to be this one. So this one. So it will become 3 then in that case. So in general, when I want to write on per pitch length basis the crushing stress induced, then I can write it simply this way. That is the dr into t into n. Okay. If that be the case, then simply what do you need to know? So what he asking us to find out, crushing resistance required. So crushing resistance force, in terms of force he is asking. So can I say dr into t n into crushing resistance? And how much will be the n? It becomes easy for you to now visualize. Simply see the number of rows. If there is one row of rivet, only one rivet, that is half or a half A. So this is getting subject to crushing. So n will become 1. If you add one more row of rivet, then half this, this becomes 2. So that means it becomes very easy for you to calculate per pitch length basis. Simply see the number of rows, and just if there is one row of rivet, the n will be 1. If 2 rows of rivet, n will be 2. 3 rows of rivet, this is going to be 3. As simple as that. Am I clear? So that is how it is going to be. You can say, find out the same is going to be for shear also. Shear के लिए भी same ही होगा. फर्क ये है कि shear and crushing के लिए you are going to have the same calculation method or same number of rivets, because over here it was getting crushed. इतना portion crush हो रहा है, but shear में क्या होगा? It is simply getting sheared. So ये portion भी shear होगा, ये portion भी shear होगा. So all the rivets will be subjected to shear. So now tell me, in per pitch length how many will be sheared? आप बोलोगे ये भी shear होगा, ये भी shear होगा. So it means half portion, this portion will be sheared, half this portion will be sheared. So n will become equal to 1. Over here also, because as you add one more row of rivet, then this half and this half will also be sheared. So again, this will become 2. So as that means for crushing formula and for shear formula, the number of rivets that you will calculate based on one per pitch length is going to be exactly the same. Okay, but when we talk about the, so in this case it becomes easy. So answer is going to be C. Okay. ND, that is NDTR, that means D means diameter of rivet, you can say. Now in case of, let us say, if I talk about in terms of shear, tensile also I can talk. Tensile resistance required per pitch length will be how much? Let's talk about the per pitch length basis पे tensile strength की बात करते हैं. Right. So this is this. This is this. Now, how do you calculate the tensile resistance? Right? You calculate based upon the when you write the tensile stress. How do you write? You write P divided by what? Width of the plate, because you have created the holes. I hope you know this. This is the, let's say, width of the plate. So if I ask you, this is the width of the plate from here to here. Sorry, just a minute. I'm applying this way. So this is the width of the plate, and if you are applying load P, and this is the diameter. That is the whole diameter of the plate. When we talk about the tensile failure of the plate, it is of the plate. We don't talk about the rivet, because if it has at all this because if at all the plate will fail, it is going to fail in tension, pulling. In rivet, you are going to have crushing and shear only. So let us say this is the diameter and this is another diameter. Let's say two holes. This is the width. Now, if I ask you, what is the maximum tensile stress developed? You will say simply see the minimum cross-sectional area and force divided by minimum cross-sectional area. What is the minimum cross-sectional area? It is going to be at the where you have created the hole. So what is the area? You will say cross-sectional area will be net width. So diameter you have to reduce. So can I say over here width minus what? 2 times D plus D. So it means 2 times diameter of hole. So this becomes the net width. नेट विड्थ कितनी हुई, इतनी, बिकॉज ये तो होल है. सो एंड थिकनेस इज गोइंग टू बी एनीवे सेम wherever you take. So this becomes the area which is subjected to tension in the plate when you apply the force P. So can I write it this way? Width of the plate minus, so net width कितनी आएगी, 2 times dh into t, as simple as that. Am I clear? So now, so in general, how can I write? Since there were only 2 holes, so I am writing it as 2, but if there are n holes, then I write it this way. Now let us say you are having a number of rows are also more, and holes, again you have not been given the width, like I had taken 2, so it is not clear how many holes are there, and therefore we again want to do the calculation per pitch length basis. So can you calculate? Of course you can calculate, but whenever you take the tensile failure, it is taken at a one cross section only, एक particular cross section, either ये इस cross section पे ले लो या इस cross section पे ले लो, that is up to you, but it is same over here. So I will simply take, let us say, at this cross section, and at this cross section of the plate, see on this length, pitch length, what is the area, क्या चेंज आएगी, फोर्स तो वही लग रही है, फोर्स तो वही लग रही है, width I am assuming equal to pitch, so pitch तो वही रही, pitch के बराबर होगी width, and can I take what is the how many this hole are over there, कितने hole हैं per pitch length पे, you will say ये यहां से लेके यहां तक d by 2, so it means the width mean pitch here is getting reduced by what, d by 2 यहां कम हो रही है और d by 2 यहां हो रही है कम. So it means effective, actual width is W, which is equal to pitch, and that width is getting reduced by the what, these diameters over here, whole diameters over here. So effective width कितनी आएगी, width minus what, width minus n over here becomes equal to what, 1, because half ये, so n becomes equal to 1, and diameter of hole into t, thickness वही रहेगी. So that means in per pitch length when we take this, so that means इस length में आपका जो width है, that is pitch, is getting reduced by the one diameter, that is a diameter d by 2 over here, ये, and इतने से आपका जो है उसका width जो है reduce हो रही है. So effective width कितनी बची, इतनी बची, effective width ये बची आपकी, कितनी है ये, तो आप देख लो, pitch minus this, so effective width ये लिख ली मैंने, into thickness of the plate, as simple as that. So can I write simply this way, या ऐसे लिख लो, but at the same time, so does it depends upon the number of rows over here when I taking the chain pattern over here, does it depends on number of rows? No, क्योंकि हम एक section पे लेते हैं. For example, in case of crushing that I explained, it depends upon the number of rows that you are taking, but over here, if these rows are even extended and if it is a chain pattern, so whether you take it at over here or over here, it is going to remain the same, because we are taking either here or here. It is not we are combining this together, because failure of the plate is going to be either over here or over here or over here, that way. So that minimum cross sectional area is going to give you the resistance, इसलिए वहां पर आपका जो है, तो if I want to find out the tensile resistance or tearing resistance, then you will say P into this, P into dh, diameter of hole per pitch length basis पे, and this is going to the answer. So I hope this is clear to you. So I think next question is based upon the same thing only. See, the tearing resistance required to tear off the plate per pitch length कितना हो जाएगा, यही, because हमने कहा था pitch कैसे था, width, force, how did we write, tensile stress induced where a force divided by the minimum cross sectional area, आपने कहा NDH into T, एक cross section पे P को हमने इसको replace कर दिया P से, N over here is always going to be 1, in chain pattern always going to be 1, एक उस section पे half diameter और half diameter ये, and therefore is going to 1 and this. So irrespective of number of rows, this is going to be remain same. See, so since I want to find out the tearing resistance over here, so it becomes equal to sigma T multiplied by P को हमने pitch लिख दिया, and this become 1 and DH. That's all. So where is, oh sorry, this is not right. This is the right formula, because over there this is going to be T also. So P minus D into T, this becomes the right answer. Okay, so see the next question, and here we have the next question for you. So on the similar lines, you have to make use of the same concept. Here you have been asked that, okay, if the efficiency of the joint, riveted joint, is given to you,
Then he's asking you to find out the diameter to pitch ratio basically. So as you know, in general we have defined how we have defined the efficiency, right? We define the efficiency of a riveted joint, that least value of any of these three strengths. Which one? We are having the tearing strength or tensile strength, or you can say you are having another one is shear strength, and then you are having this crushing strength. So out of these three, whichever is less, right, that we call as the strength of the riveted joint, right? So divided by the strength of the unriveted solid plate, unriveted solid plate, right? So that is how we define the efficiency of the riveted joint. But what he is asking you, he has given you the tearing efficiency. So let us say I can also individually define these efficiencies. For example, I can define the tearing efficiency, that means the tensile efficiency of that riveted joint. I can define the shearing efficiency of that joint. I can define the crushing efficiency of that particular, or bearing efficiency. Crushing or bearing means the same. Crushing or bearing efficiency of that particular joint. So in that case, how I am going to define? I will say, if you modify it, if I say tearing efficiency, then I will say the tearing strength. I will take only the tearing strength divided by, again, this is going to remain the same. The comparison is to be done with the unriveted solid plate. There is no hole drilled in that plate, or that you are having a solid plate, as simple as that. So I will say tearing efficiency means tearing strength, tensile strength divided by unriveted solid plate. It is going to remain the same. Or let us say if he is asking you to find out the crushing efficiency, then how you will define the crushing efficiency? You will say crushing strength of that riveted joint divided by, again, comparison is with the unriveted solid plate. And let us say if he is asking you to define the shearing efficiency, then you will say what is the shear strength of the riveted joint? That is the maximum load that it can carry in the shear, right, divided by, again, the unriveted solid plate, strength of the unriveted solid plate. So I can also individually define the efficiency of that particular joint. So that is why he has mentioned over here. So he has given you the tearing efficiency of the riveted joint. So what I need to do is, so tearing efficiency of the riveted joint is to be the tearing strength of the, or the tearing tensile load that this joint can carry divided by the strength of the unriveted solid plate. And you already know the strength of the unriveted solid plate is basically the tensile strength of that particular solid plate. So how you are going to write it? So but the point is that you have not been given the width. So again we have to carry out the calculation on the per pitch length basis. And how you do that? In last case also I explained you. So let us say if I see on per pitch length basis, let us say, so on per pitch length basis, how you can define the so let us say if I take, you can, for simplicity, as I told you, you can take this distance as pitch. So it is same distance as you had from center to center, but it is easy for you to imagine, right? So now what I need to do is I need to assume this pitch equal to the width of the plate. So that means if I take the width of the plate equal to the pitch, then I can carry out the whole calculation on the per pitch length basis. Now let's define the efficiency, tearing efficiency of the what? Tearing efficiency of this riveted joint. So tearing efficiency is going to be what? You will say tearing strength or the tensile strength of the joint on per pitch length basis. That is the meaning of tearing strength, and the strength of the unriveted solid plate. Now I don't know the width of the unriveted solid plate, but I know that I have taken the width equal to the per pitch. So what I can do is I can take a plate whose pitch is equal to what? Let us say whose width is equal to pitch. So if I take that width equal to pitch, then this becomes the width of the plate for me to carry out the comparison, and thickness obviously is going to remain same whether I do this way or maybe whatever way. So that means over here I am going to calculate the tensile strength of this particular plate without any holes on per pitch length basis, equating the width equal to the pitch. So can you give me the, or in this case, because you are applying the load, obviously you are applying the load this way. So what is this strength? So basically this is the tensile strength of the plate only. So what is the tensile strength? You will say, obviously you will say, because it is in terms of force, then you will say allowable value of the tensile stress that this plate can carry multiplied by the cross-sectional area. What is the cross-sectional area? Width, which is equal to pitch. So can I say this is width, and what is the thickness? T. So this becomes the tensile or the strength of the unriveted solid plate, or tensile strength of the unriveted solid plate, meaning is same, because we will calculate, obviously this will be the tensile strength only. Now what is that tearing strength or tensile strength of this particular riveted joint? So in that case I have to calculate. How do I need to write it? So tensile strength again. So what is the width? Width means, because now you have done the hole. So if you have done the hole, in this per pitch length, that hole which you have done will be of diameter d, then obviously width got reduced by diameter d. ये जो diameter है आपका इतने से क्या हो गया वो, that width got reduced. So what is the effective width? Effective width will be what? So you will say effective width will be, width you have taken equal to pitch minus what? Pitch minus diameter. This becomes the effective width, whereas in this case it was equal to the pitch, and thickness in this case as well as in this case it is going to remain same. So this becomes the what? The cross-sectional area. And if you will multiply the allowable value of the tensile strength, because we are calculating the tearing efficiency, so it is going to remain same because it is the same plate. So over there it is going to remain same, multiplied by PT. That's all. This becomes by tearing strength. Same way as I told you, you can write for the crushing strength also. The only term that is going to be changed is this term. This term is going to remain same on per pitch length basis. So this term is going to change in case of crushing strength. That's all. So allowable value of crushing stress multiplied by the projected crushing area of that particular joint. As simple as that. Same way, if he is asking the shearing, if he has given you the shearing efficiency, in that case this term is going to remain same. Only change is going to be on this term, where you are going to input the value of the shear strength of that particular joint on per pitch length basis. As simple as that. Now rest is, you can just cancel it out, and T will cancel out. So you are left out with what? So if I divide it with this 1 minus d by p, this is what I am remaining with. So just see, what is it? He has given you the tearing efficiency as 50%. So that means this becomes the 0.5, and he is asking you to calculate the diameter to pitch of that particular rivet. So diameter to pitch becomes equal to, again, this goes to that side, so it becomes equal to the, again, the 0.5, that is the, it becomes the 50%. So that means, or 0.5 he has given you, so, or you can simply say diameter to pitch ratio he has asked to calculate. So this is going to be the this. So don't get frightened if he individually asks you to calculate some kind of information, like based upon tearing efficiency, crushing efficiency, or shearing efficiency. Only you need to have the your concept intact. That's all. Okay, that is how you are going to approach this particular problem. Let's go to the next one now. For longitudinal joint in boilers. Now here you need to have a clear understanding of what is a longitudinal joint and what is a this circumferential joint in the boilers, right? So the type of joint used is what? So I hope you know, you have the idea that how basically when we used to, nowadays, you know, we don't make those boilers with the riveted joints, right? Because welding technology has already advanced to a certain level. So we go for the welding of those particular those sheets or plates that we make use of in order to make those boilers. But earlier, when we were not having that much advancement in welding technology, we used to make the boilers with the help of the riveted joints. So now this is how the riveted joints. So let's say I have just taken this. This is basically a boiler, right? It's a kind of cylindrical pressure vessel you can just think of, right? So this is how the situation is. So how do you make that boiler? Earlier you used to have a, first you need to have a sheet and you have to fold it. So if I am folding the sheet, then you are having a one, this is a cylinder, right, of certain thickness. This is what I have made. So something this way, okay, right. This is what I have made. Now what I will do, I fold it and then I will just produce a joint over here by folding it. So that has been shown to you over here. For example, one portion is this, another portion is over here. So this anywhere, maybe here you have formed the joint. You have taken the sheet and you have folded it. Now I am having this particular joint. Same way. So this joint is longitudinal. Somewhere you have folded it. Let's say you have produced a joint over here. So this is the longitudinal joint. Because why longitudinal joint? Because you have produced the joint over here along its length. That is why longitudinal joint. So let's say if the length of the boiler is more, so you can take one more shell, same kind of shell you can take, and then again you are having this kind of configuration that you have to have, right? So then again what you need to do, you have to join them again, and at the ends also you need to have some kind of cup shape that you need to join over here. So you will produce a cup of something this shape, again it is a cylindrical, and you will at the ends this portion. So somewhere here you are going to produce a joint again, right? Here also you are going to produce a joint, or in the middle also. For example, when you will join these two portions, so here also you are going to produce a joint, and in the other end also you are going to have that particular cup shape that you have to ends. They may be cylindrical or hemispherical that you need to join. So depending upon how much is the length, it may happen that okay, if length is not that large, so what you can do is you are taking this one, and then you are taking one end from other side, this side, and this one other end from this side. So closing it as a single, that is also possible, right? Depending upon the requirement. So now you are having three joints. Let's say if you two types of joints you are going to have. One is that is a longitudinal joint along the length, because you have to fold the sheet. At the ends also, when you have to connect it to this over here, when you have to connect these two ends over here, or these two ends over here, or these two ends over here, so they are the circumferential joint along the circumference. Over the circumference, over the circumference, over the circumference, you are going to have the joint. So one is over here in this particular this cylinder also you are going to have longitudinal joint over here, longitudinal joint over here, and the others that you see are the circumferential joint, and the same has been shown to you over here. Now this is the longitudinal joint, this is a longitudinal joint, this is a circumferential joint, let us say, ends maybe it has not been shown, but anyway there could be also joint over here as I explained you. But anyway, point is, now this is a boiler, is a pressure vessel, and it is subjected to what? It is subjected to internal pressures, internal pressure. So obviously you have already seen those thin pressure vessels, right? You have already know the stresses. So if I ask you, this is the stresses, this is a joint that you have formed. Now if I ask you what is the, if you take any element over here, let's say I take any element over here, then on this particular joint, let's say if I take this element over here, if I ask you what are the stresses acting because of that internal pressure, you will say obviously one is going to be this way, other is going to be this one. If I ask you what are these stresses, you will say obviously this is the longitudinal stress, right? So this stress that you are having over here is the what? Longitudinal stress, and this stress that you are going to have is the hoop stress, right? Same way over here. If I take the element over here this way, right? If I ask you what are the stresses, you will say this is the stress. What is this stress? And what is this stress? Obviously, since this is acting along the length, you will say longitudinal stress, and this is the hoop stress, circumferential stress or tangential stress that is acting over here is the hoop stress. Now, which one of these two is larger? You already know hoop stress is greater than the longitudinal stress. Hoop stress is PD by 2T. Hoop stress is PD by 2T, whereas longitudinal is PD by 4T, right? So that means hoop stress is greater than longitudinal stress. Now, it means this weld, not weld over here, this particular joint is getting subjected to a larger value of stress, right? So it means if this joint is getting subjected to a larger value of stress, then this must be strong so that it does not get separated this way. So if that has to be, so longitudinal joint, so this longitudinal joint is getting subjected to hoop stress, because hoop stress is larger, so hoop stress will try to separate it. So that means this joint should be stronger. Then what? Then this particular joint that is over here, that I will explain later stage. Same way if you see over here, then this particular try to separate anywhere, right, this way. So this is the hoop stress, which is larger in value out of these two, will try to separate this joint, longitudinal joint, and therefore what we will do is we have to make this joint stronger, because hoop stress value is the larger value. And you know, out of those two lap joint and the butt joint that you are having, butt joint is stronger than the lap joint. So that is why we produce this joint that we make over here along the length. For example, when I folded it, so I will not just overlap this plate. After folding the sheet, I will not overlap it, but I will butt it, and then I will use the cover plates. That means I will make it as a butt joint, because butt joint is stronger than what? This lap joint, right? So that means for longitudinal joint, this one as well as this one, this one as well as this one I will use the double strap butt joint. That will be the more stronger even than the single strap butt joint. So I will use the longitudinal joint subjected to circumferential stress usually made is more critical. Larger value of stresses are acting, and therefore I will make it as a double strap butt joint. So over here, one plate outside, another plate inside. So this becomes a double cover butt joint. This one also and this one. What about the circumferential? So I hope you understood this now. Now I will talk about the circumferential. So over here, this is the circumferential joint, let us say, if I take only one. So over here, let us say this is a circumferential joint. So over here, if I take the element anywhere on the circumferential joint, again, over here, tell me how the stresses are acting. You will say this is the hoof stress and this is the longitudinal stress. Hoof stress and longitudinal stress. So it means this joint, that is the circumferential. Now this is the circumferential joint. So circumferential joint is getting subjected to what? If it has to separate, it has to break, it will break this way. So that means circumferential joint is getting subjected to the longitudinal stress, which is less than the hoof stress. It means I don't need even to make this as strong as you are making it, because the longitudinal stress value is less than the hoof stress, and therefore I can make that joint not as strong as the longitudinal joint. So that is why normally the circumferential joint that is made is the lap joint. So what I will do, I will take the end, like as I explained you over here, I will take these two ends and therefore overlap them. I will overlap them and then I will carry out the riveting over there. So that is the lap joint. So it will try to separate, but because since the stress acting is lesser than the hoof stress, and therefore I can go for the lap joint also. So that is how is the basically understanding of this. And see, this is how, if you want to picturize. So this is way, right? This is one strap that is you are using over here. One is the internal strap, same, and this is the external strap on the longitudinal strap. So double strap butt joint along the length is produced. That is a longitudinal joint is the double strap butt joint, whereas the circumferential you are seeing this is overlapped over the another, and therefore this is a lap joint. So if you have that understanding, I think you can now answer this. For longitudinal joints in the boilers, the type of joint used is what? Butt joint with double cover plate. Obviously, so you have to go for the butt joint, because you cannot go for the lap joint, because lap joint is weaker than the butt joint, and since the longitudinal joint is subjected to the larger value of those two stresses, and therefore I have to make it more stronger. So B is going to be the correct option. Let's go to the next. The tab bolt has, so you know you are having different types of bolts, right? You are having through bolt, you are having this tab bolt, you are having studs, etc. So out of these three major types of bolts, or you can say screws that you make use of, tab bolt you should have the understanding, right? So try to get the idea from out of these options. If you can find the answer, then it's okay. If not, then you are having the explanation over here. I hope you will be able to understand it by looking into the configuration itself, right? So just have a look over here. This is basically the tab bolt. In tab bolt, normally what you do is, you don't have to use the nut at the other end. So when you use the nut at the other end, like when you pass that particular bolt and at the other end you use the nut, then we call it as a through bolt. But when you don't have to use the nut at the other end because of many reasons, then that kind of bolt we call it as a tab bolt. So what you are going to do is, for example, let's say this is the part. So on this part, and in those situations where the part is large enough and therefore we don't have space to accommodate the nut. अब nut ना use करने की जरूरत कहाँ पड़ी? Either this particular part in which you are going to join these two parts, one plate and the other bigger part. So this part does not have either space to accommodate the nut, or this is large enough so that I can use the nut at the other end. So in those situations, I will go for the tab bolt. So in tab bolt, what you are going to do is you are going to do the hole in this larger piece, and then going to do the threading, internal threading, and that internal threading we call it as a tapping. I hope you know. So that is why the name came as a tab bolt. So what you have done is you have drilled a hole in the larger portion, larger that particular part, and you have tapped that hole. That means you have produced the internal holes, internal threads, and then what we will do, we will pass that bolt from the hole drilled on the other plate which is of smaller size, and then obviously we will screw it inside that particular tapped hole. So that is why that kind of situation, this bolt came to be known as tap bolt. I already explained you the reason why normally you need to go for this particular kind of configuration. So when you don't have sufficient space, or maybe part is thick enough so that it can accommodate the nut, right? So that means now you can go for head at one end and the other end fits into the tapped hole. Tapped hole means threaded hole of one of the parts to be fastened, right? Obviously when you have to connect two parts, so one of those parts is bigger enough. So this is the B option that is going to be the correct answer. Okay, this is a very relatively simple answer question. That is the largest diameter of an external or internal screw threads is known as. Now this is part of your understanding of basic terminology of the screw or threads, screw threads or bolt threads, whatever you call it. So I hope you understand this is somehow something, the terminology part. So largest diameter, when we call for any the largest diameter is basically crest to crest diameter. This is the crest of this bolt. For the bolt, this is the crest to crest diameter. This is the largest diameter. Whereas for the nut, it is the root to root. So this is the root of this particular thread. The crest is this. So this particular nut, this is the root. So root to root diameter over here for the nut, and the crest to crest diameter in case of a bolt is called as the larger diameter. Other name given is the largest diameter, and the name given to is the major diameter. So in this case I will call this, if you see, this is the D, that is the largest diameter that is taken over here, and over same thing it has been represented by the capital D over here. So pretty simple to answer. So that means largest diameter of external or internal screw thread is known as basically major diameter. This is a standard terminology, is nothing special in it. So these terms should be clear to you, that's all. Now see, a bolt of M24 by cross 2 means, now for this basically this is a ISO metric, this is a specification kind of thing, you can say, how do we specify the ISO metric threads. So kind of a nomenclature is used which is given to you over here. And if you have the understanding, for the coarse threads, we are having two types of threads. One we call it as a coarse thread, the other one we call it as a fine threads, right? For any particular nominal diameter, let's say if I take the 50 mm nominal diameter, against that I can make the threads of different pitches. Let's say I am taking 5 mm, 2 mm, 4 mm, hypothetically I am taking, let us say 2.5 mm, 1 mm, and maybe like you are saying 0.5 mm or something this way, right? Randomly I have taken. So when we say coarse thread, then corresponding to this nominal diameter, basically this is the major diameter. How would you, one thing that you should know, that when we specify any particular bolt or a thread, it is specified by the nominal or the major diameter of that bolt. So this is the nominal or major diameter of the bolt, against which these are the pitches which we can make. So when we are having a bolt of any particular diameter, nominal diameter, corresponding to that particular largest pitch that we can make, we call that thread as a coarse thread. And if we make any other threads, if we make any other pitches other than the largest pitch against that particular nominal size, then we call that as a all other threads as a fine threads. And to specify the, as per the isometric threads, to specify the coarse threads, we use the terminology M stands for metric specification, M, and the simply what we will do, nominal diameter 50 m, 50, that's all. It is understood that that is 50 stands over here for 50 mm, that is the nominal diameter, M for metric specification. So that means the manufacturer is going to make, as per this specification, this is a specification for the coarse thread. So against this, the manufacturer is going to make the thread which is having a pitch of 5 mm. It is understood, because you are not specifying the any kind of pitch. But for specifying the fine pitches, what you need to do is, you also need to specify the value of the pitch, because all these pitches belongs to the fine threads. So which one I have to make? So in that case, what you do for fine threads, you will say, let us say I want to make a fine thread, I will separate it by cross. Let's say I want to make a 1 mm. So you will say this way. So basically, if you see over here, this is the specification for the fine threads. This is for coarse threads. So he is asking the meaning of this. So see, this should stand for the nominal diameter or major diameter of that particular thread or bolt, which is this. and it should be in mm. Same way, 2 should stand for the what? Pitch of that particular fine thread that you want to make. Let us say out of these which pitch you want to make. So you need to specify that particularly. So this is for the that. So rest I think it is clear. So it is a 24. That means that the nominal diameter of bolt is 24 mm. Automatically this means 24 mm. This 50 means what? 50 mm. 1 what? Mm. 1 mm. And pitch is 2 mm. As simple as that. So if you have that understanding, I think you can interpret it very closely. He may give you, M24. If he had given you M24, it means he is referring to what? He is referring to coarse thread of 24 mm nominal diameter. But in that case, he because these details, what is the pitch? So pitch you will not be able to get it. You will be able to get it from the that particular standard or kind of standard that you are having or manual that you are having. From there you will be able to get. The same thing has been explained to you over here. So let's go to this one. Just see this and try to find the answer. See, when a bolt is subjected to external load, now he is not giving you even the external load. What kind of external load is? When the bolt is subjected to an external load, the stress induced in the bolt will be what? Now for that you have to go for the basic configuration, right? For example, let's say this is how we normally, let's say this is the basic configuration that you can talk about, but how we are applying the load he is not mentioning. But to answer the question, I can even answer this question based upon my understanding. For example, if I am applying the load over here, can you let me know what are the different types of stresses which are getting induced in the bolt? Obviously, it will be pulled up, which the bolt will be pulled out. Definitely, you are going to have the shear stresses. Not only, sorry, this is the tensile stress because it is getting pulled. So obviously, this is the tensile stresses will be generated. What else? Will there be other stresses also? Definitely, there are going to be other stresses also. What are those stresses? You are going to have the stresses in the portion where that nut and bolt is in contact. One is the bearing or the crushing stresses also, and shear stresses also. Shear stresses between the threads of one, that is bolt, and that particular nut will try to shear each other. Like this came out from this, that is from the base of that particular they will try to take them out. So it means load is acting parallel to that particular peripheral area. That means it is getting subjected to shear. As simple as that. That means in this configuration, if you are applying the load this way, then you are going to have the tensile stresses as well as you are going to have the shearing stresses. You are going to have the crushing stresses also. This is one. Other way around also, if you see, if I ask you that if I apply the load this way, this could have this type of situation also can exist, like you have been discussing in riveting. It depends, all depends how you are applying the load. It is not always that you are going to apply the load the way I explained. You can apply the load this way also. Now if I ask you what kind of stresses will be developed, just imagine the situation in riveted joints. This portion, for example, if I am pulling from this side, then obviously this area is getting crushed, half portion is getting crushed. Over here, this will be pulled this way, right? This plate will be pulled this way, so this portion of the bolt and this plate will be crushed. Whereas when you are pulling it this way, then this portion of bolt and plate will be crushed. They are crushing. At the same time, you are having the interface over here in between, over here, because these are two different plates. So they will try to shear this way. So that means shear stress is also acting, crushing stress is also acting. There is no single stress which is acting over here. So if you have that much idea, I think you can answer this question. Just have a look. In one of the case, he has given you tensile stress, shear stress. Shear stress can also induce. Tensile stress can also induce. But it is not that only shear stress will be induced. It is not only that tensile stress will be induced. That will depend upon the situation. Combined tensile and shear stress, it is possible. One configuration that I told you, when I am applying the load vertically over here in this configuration, that means tensile and compressive. So it means combination load is possible. So any one of these, this is not possible. That is pure shear. In this configuration is only shear. That means not pure. That means only shear may not be justifiable. So the most appropriate answer that you are going to have, or that looks like over here, is going to be the combination of load that is going to act over here. That is the combined tensile and shear stress, and that too will be in the configuration when I am applying the load. How? When I am applying the load this way, which he has not clarified. If I apply load this way, so you are going to have combined load. But if you are applying the load this way, then the combined tensile load example, that answer he has given. So over here, then it is not going to be the correct. So that means sometimes if the question there is this the question is not very crystal clear, in that case you have to get the best out of all these options. So in this case you can just think of that he may have thought of like framing the question that load is being applied that way, and therefore it is going to be a combination of load, tensile and shear stress. Let's go to the next one. In a flange coupling, the bolts are subjected to. So for that you need to have the idea of the flange coupling. What is a flange coupling? Right? This is a flange coupling. All of you may be having little idea. That means when we want to transmit the torque or power between two shafts, then we make use of the flanges, which may be separately attached to those shafts, or maybe sometimes they are built in with that particular shaft. So what we do is we are having these flanges which looks like, and we make use of these bolts over here. And then obviously this is something this way you transmit, they have been joined on the periphery, you are having the bolts, and when you supply the power from one side, then obviously it is going to pull it along with it in its own direction. So if that is the case, then just think of the situation where you are having the flange portion. This is the flange portion over here. This is the flange portion which is looks like over here. This is the flange portion, okay? Yeah. Right. So ये जो portion है, this is the flange. This is the hub which has been created to join to the shaft. Now you are having the holes where you are going to use the bolts and tighten with the nut. Now think of the situation, what kind of stresses will be developed, which can be you can visualize very easily. Let's say if I want to transmit the torque from this side or power from this side, then if you are having a bolt over here which you have joined, you will try to take that bolt this way, because interface is over here, so you will try to shear the bolt. Torque is acting, so it will try to shear the bolt. So that means at the interface, in any case, you are going to have the shear force. Not only the shear force, but also you are going to have the crushing over here. At the over here, that means where you are having bolt crushing that particular the flange portion. That means in this portion, half portion somewhere, right? In this half portion of this, so crushing is also going to act. But crushing is not that significant or critical as is the shear. So the decision, even though you know that there is going to be crushing also, there is going to be shear. Shear in any case is going to be critical and will be over there. So the decision which one to choose will be taken by you over here in this question. So as I have told you, have to decide sometimes based upon the best out of all those options. For example, tensile stresses over here, there is no logic of having the tensile stresses. Compressive stresses, there will be. Shear stresses, there will be. But out of these two, which one is a significant that you need to choose. So that is why I am saying that you need to find out the best among all these. So even though this is also correct, this is also correct, had he given me the option of compressive as well as the shear stresses, I may have gone for that. But here that option is not given, so I will be left out with no option but to tick this option, because compressive stresses are not as significant as the shear stresses in case of flange coupling. So that is how you have to answer this particular question. Okay, so let's go to this. And eye bolts are used for. Now eye bolts, simply if you have the idea what are the eye bolts, then you can, let's say I think all of you may have seen the electric motors which you are using at household level also for pumping the water also and all that. So on the top of that, normally we have kind of a eye bolt normally is provided. For example, let's say this is particularly to lift the heavy machinery. Let's say this is some kind of a bigger machine which I need to lift, transport. So when I need to lift, then what I do take. So normally what we have done is we have a tapped hole at the top, right? So what we will do, we have a tapped hole at the top. So maybe there may be multiple tapped holes that I may have done. So here you have the threads and all that. So what I will do is I have this is a bolt, right? And down there I have a shank portion. And in this shank portion, I have threaded that shank portion, right? So now I can just screw it on the top of that machine, right? So why this is the eye this is the eye of the bolt where I can insert the hook and lift it. So that multiple such kind of eye bolts, you can screw it on the top of that machine, and then by making use of the hook, you can lift that particular heavy machine. Once transported, you can remove these particular eye bolts, something that way. So these are called as eye bolts. So you can just see, if you have that idea, lifting and transporting heavy machine, that's all. That is the rest are just not matching. So this is how you are going to answer. So these are some of the questions that are over here. Some of the other questions on the related topics I'm going to discuss with you in this particular series. So see you in the next session. Till then, bye, and keep watching these all the questions, and they are going to be relevant and most appropriate from your exam point of view. So bye for now, and see you in the next session.